Well, now that we know the sampling distribution, let's look at how we would calculate a confidence interval for this. So remember, every single confidence interval in the world is estimate plus minus margin of error. Every single confidence interval in the world. Estimate, how do we estimate the difference between the two proportions? Well, it's p hat 1 minus p hat 2. What's the margin of error? It's the star times the standard error. So in this case, these should all look familiar. This is the mean, and this is the standard deviation. That's why this piece back here is called the standard error, because really it's just the standard deviation. Okay. Now, how confident do we want to be? Remember that P like Z, pizza. So this is a proportion. We're going to be using Z star. And we can find Z star in the table. Table B will give us the Z star values. Just like before, it's all based off of the normal curve and the critical values, the cutoff points for these intervals. Okay. Now, remember, what are we going to do? Oh, we're going to estimate the true difference in the proportions of whatever the problem's about. Are we allowed to do it? We have to check conditions. And we kind of referred to these conditions on the previous page. Okay. Is it random? The only way we know is they tell us. Did they tell us it was an SRS? That's how we check SRS. The reason that we have this random condition, if the data was not random, then we cannot extend our findings to the entire population of all goldfish, okay, or whatever the problem's about. The 10% sampling without replacement. Okay, what this one's saying is the data independent. Okay, is the population at least 10 times the size of the sample? Okay. Remember, N1 is the sample of the first one. So in this case, that would be the first bag, which was 50. And the capital N1 is the population from the first sample, or the population that we gathered the first sample from, and there were more than 1,000. So we checked these conditions on the previous example. And then large counts. This is what tells us, is it normal or not, where we checked that earlier too. N1 times p hat 1 and so on all have to be greater than or equal to 10. Okay. Now let's put this to practice. Okay. Patients with lower back pain are often given non-steroidal anti-inflammatory drugs like naproxen to help ease their pain. Researchers wondered if taking Valium along with the naproxen would affect pain relief. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of the two treatments. Okay. Either they got the naproxen and Valium, or they got the naproxen with the placebo. After 1 week, 39 of the 57 subjects who took the drug with the Valium had reduced lower back pain, while 43 of the 55 in the other group had reduced lower back pain. Sorry, I had trouble getting that out. Okay, so construct and interpret a 99% confidence interval for the difference in the proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium versus the naproxen and the placebo. So we need to construct a 99% confidence interval. For what? For P1 minus P2. Well, what is P1 and P2? So P1 is the true proportion of back pain sufferers who got relief using naproxen and Valium. Okay, I don't want to take the time in the video to write out P2, but what is P2? It's the true proportion of back pain sufferers who got relief using naproxen and placebo. So we know we have now defined our parameters. So I'm not going to write all of this out again, but you would need to spell this out for them again. What is P2? What are we trying to estimate? Okay. Now, what are we going to do? This is called a two proportion Z interval. So what's our plan? How are we going to estimate this difference? Okay. So what are we going to do? Step one, we told them what we're going to do. Okay. Step two, are we allowed to do it? Well, was it an SRS? It says that the patients were randomly assigned. Okay. So, yep, the data comes from a SRS. It is random. Now, is this distribution normal? Well, if it's normal, then P hat 1 times, N1 times P hat 1 and N2 times P hat 2 and N1 times 1 minus P hat 1 and N2 times 1 minus P hat 2 all have to be greater than or equal to 10 if it's normal. Well, let's find out, what is P hat 1? Well, they told us that in the first sample, 39 of the 57. And in the second sample, 43 of the 55. So we're going to have to convert those to proportions. So if we do that, we'll see that P hat 1 is 0.684 and P hat 2 is 0.782. So now I know that N1, in the first group, there were 57 subjects. And in N2, the second group, there were 55 subjects. So now I'm just going to plug and chug into this formula. So it would be 57 times 0.684 and 57 times 1 minus 0.684 and 55 times 0.782 and 55 times 1 minus 0.782. They all have to be greater than or equal to 10. I'm not going to type all these in, but you will see that, yes, they are all greater than or equal to 10. Now, is it independent? Are we allowed to use the formula for the standard deviation? Okay. Well, are there more than 57 back pain sufferers who use naproxen and Valium? We'd have to assume that there's at least 570 men in the population who have lower back pain who have tried those two drugs. Are there more than 550 men out there who have tried the naproxen without any other drug? I'm sure there are. So we're okay there. What we just did was figured out, yes, all right, we are allowed to do this problem. So what are we going to do? We're going to construct a 99% confidence interval for the proportion of back pain sufferers who got relief using naproxen and Valium minus the true proportion of back pain sufferers who got relief using naproxen with a placebo. How are we going to do this? By making a 2-prop Z interval. Are we allowed to do it? Yep. Populations at least 10 times the size of the sample. Subjects were randomly assigned and large counts. They were all greater than or equal to 10. So cool. We are allowed to do it. Okay. We told them what we're going to do. We checked to see that we're allowed to do it. Now let's do it. Unfortunately, I need to clear all of this off of this page, which kind of sucks because I kind of need this data up at the top. We said that N1 was 57. We said that N2 was 55. We said that P hat 1 was 0.684. And we said that P hat 2 was 0.782. Okay. Let's construct the confidence interval. So you remember from the previous page, it was p hat 1 minus p hat 2 plus and minus z star times the square root of p hat 1 times 1 minus p hat 1 all over n1 plus p hat 2 times 1 minus p hat 2 all over n2. All right. Now, really, in the real world, we're not going to do this calculation by hand very often. So what is p hat 1? Oh, 0.684 minus 0.782. Plus or minus, where did we get the z star from? So remember table B. We would look at the z star in table B. Now that table is going to be given to you, something that you can refer back to at all times. The z star for 99%, I'm not going to show you right now, but is 2.576. I just looked that up in the table, and I'll show you that here in a few minutes when we do another example. So I'm just going to write all of this out. Now it's 0.684 times 1 minus 0.684 over 57 plus 0.782 times 1 minus 0.782 all over 55. And I'm going to do all of those calculations, and it's going to spit out an interval. My interval is going to be negative 0.312 to positive 0.116. Let's take a look at how we're probably going to do this example the majority of the time, and that's going to be on the calculator. So I wanted to run an interval. Remember, we need to go to stat test to find our tests and interval. Well, what kind of interval? Well, you remember what we wrote? A 2-prop z interval. So these first things are tests. Let me scroll down. There's a 2 sample, a 2-prop z interval. That's the one I want. Now it's going to ask me X1. Well, how many in the first group received or had relief from back pain? Oh, that was 39. Out of how many? Oh, 57. In the second group, how many had relief? 43. Out of how many were in the second group? 55. How confident do I want to be? Oh, I want to be 99% confident. And then I say calculate. And it gives me the interval negative 3.114 to positive 0.11623. Notice on the calculator, these values are slightly different than what we got when we did it by hand over here. And that's just because the calculator carries more significant digits and is slightly more accurate than what we did by hand. Okay. So you can see that we can use the calculator to construct this interval, which is what we'll do 99% of the time. Almost always we will use the calculator to do the heavy lifting for us so we don't have back pain later on. All right. So I did step 1. I defined my parameters and I explained what I was going to do. And I told what method I would use. I did step 2. I checked to make sure, am I allowed to do it? Is it random? Yeah, we randomly assigned them. Is it normal or large counts? Yeah, they were all greater than or equal to 10. Is it independent, or is the population at least 10 times the size of the sample? Yes, it was. Step 3, I did it. Here it is. Now, step 4, probably the most important. What the heck does that mean? What did I just find? What was I doing? What is that interval? Okay, so let's step 4, write our conclusion. Conclude what we just found. We are 99% confident. We will start our conclusion every time. So interpret the results in context. Conclusion. Interpret the results in context. Interpret the results in context. We are 99% confident that somewhere between 31.2% less to 11.6% more patients got relief when? What did we do? We subtracted the volume minus the other one. So we are 99% confident somewhere between 31.2% less to 11.6% more patients got relief from naproxen plus Valium than naproxen alone. So let's look at question B now. So we are 99% confident somewhere between 31.2% less of the back pain sufferers to 11.6% more of the back pain sufferers got relief from the naproxen plus Valium than that of the naproxen alone. Based on this interval, what conclusions can we make about whether taking Valium along with naproxen really is effective in your pain relief? Because this interval here contains 0, since we're 99% confident that there could be no difference in those two proportions, our conclusion is that there is no difference in the two medications for pain relief in your lower back. Since 0 falls within this interval, we cannot conclude that there is a significant difference between one treatment or the other.